Okay, so notes 9 is over solving equations using the zero product rule. So yesterday we talked about how to factor those equations. Now we're going to go one step further and take those factors and solve. Okay. So we're first going to look at the definition of a quadratic equation, then the zero product rule, and then finally how to solve by factoring. Okay. So it says definition of a quadratic equation. We mentioned this a couple times in previous notes. You just need to know that this is the standard form for a quadratic equation, and that is ax squared plus bx plus c. And now we have it equal to 0. So in order to solve, this has to always equal 0. Which means if it doesn't equal 0, then we're going to have to manipulate the equation to where it is equal to 0. And then the zero product rule states that if we have two factors, and here they labeled these two factors as A and B, if we multiply those two factors together and they are equal to 0, that means either A or B has to be equal to 0. Which makes sense because if you were multiplying two numbers, let's say 5 times a number would have to give us 0. 5 times 0 would have to give us 0, or vice versa. It could be opposite. So in these first couple examples, they already factored it for us. So they gave us our two parentheses, and they're saying our parentheses are equal to 0. So since it's already factored, we can say by the zero property rule, we can set them separately equal to 0. So this would be x minus 4 equals 0 and x plus 3 equals 0. Okay, so I took each of the parentheses, I removed those parentheses and set them equal to 0. Okay. And then for each of them, I'm just solving for x. So in this first one, I'm going to add 4. So I have x is equal to 4. That's my first answer. And then what would I do for this one? Minus 3. So I have x is equal to negative 3. Okay. So those are my two answers for this quadratic equation. Okay. So again, this first step, we're just practicing taking those factors and setting them equal to 0. And then on the next part, we're going to combine yesterday's notes with today's notes, and we're going to do the process of factor by grouping and then set them equal to 0. So then for this next one, we have x plus 1 times x minus 8 equals 0. So I'm going to set them each separately equal to 0. So x plus 1 equals 0 and x minus 8 equals 0. And then I'm going to solve. So on this one, I'm going to subtract 1 over. So I have x is equal to negative 1. And then what can I do with this next one? Add 8. So I have x is equal to 8. So these are my two answers to this problem. X is equal to negative 1 and x is equal to 8. Okay, go ahead and do this one on your own. Okay, take a minute. You're still doing the same process. You're setting them each equal to 0 and solving for x. And then when you're done, you can compare with a neighbor. Okay, so setting up the problem, you guys should have had x plus 8 equals 0 and 4x plus 1 equals 0. Okay. And so when you solved the first one, what did you get that x is equal to? Negative 8, because I subtract the 8 and I get x is equal to negative 8. That's my first answer. And then in this next part, we had to do 2 steps. So first we were going to do what? Subtract the 1. And so I have 4x is equal to negative 1. And what would be my next step? Divide by 4. So you could leave this as x equals negative 1/4. Just leave it as a fraction. Or you could write this as x equals negative 0.25, which would be the decimal you get if you type it into your calculator. Okay, so either of these would be correct. For college algebra, what I would get into the habit of is leaving everything in terms of fractions. Okay, because they're going to want everything in terms of fractions for college algebra. Okay, so definitely if your goal for this course is to go on to college algebra, then I would practice leaving everything in fractions. Okay, but if you forget on the test and you put it in decimal, you'll still get the credit. Okay. Okay, so this one, same thing. We have 2 factors. We're going to set each equal to 0. So 4x minus 5 equals 0. And then x plus 6 equals 0. Okay, so then for that very first equation, what would be my first step? Add 5. So I have 4x is equal to 5. And then what would be my last step? Divide by 4. And I want to leave it as a fraction, so I have x is equal to 5/4. 5 over 4. Which is 1 point something if you plug it into the calculator. And then for this next one, I subtract 6. And so I have x is equal to negative 6. So again, on these examples, they factored it for us, and we're doing the solving part first. Okay. Okay, now looking at this example, notice that we no longer have 2 parentheses. We just have an x outside of there. When you see this, I want you to draw parentheses around that x. Okay? Because we're still going to use the 0 product rule that states one of these have to equal 0. Which means we're still setting each of the parentheses equal to 0. So this is x equals 0 and 3x minus 7 equals 0. So that means this one is already solved. I don't have to do anything else but say that is equal to 0. X is equal to 0. Okay. Go ahead and take a minute and solve the next one. Okay, so the first thing you should have done was add the 7 over. So you get 3x is equal to 7. And then what would be the next step? Divide by 3. So you get x is equal to 7/3. And again, just leave it as a fraction. I think also in Alex, they might want you to leave it as a fraction as well. So it's just good to get into that habit.
Am I able to convert it to a whole number, like 2 1/3? Or no?
It would be,
Proper fraction.
typically they are kept as improper fractions. I am not too sure if Alex would accept 2 1/3. You could always try on one question and see if it does. But in college algebra, it's left in improper fraction. Okay. Okay, go ahead and try this one. And then when you're done, you go ahead and compare with your neighbor. Make sure you guys got the same answer. So what did you guys get for the first x value? X equals 0. And what did you guys get for the other x value? Good, so 4x plus 9 equals 0, which solves to what?
9 over 4.
Close, negative 9 over 4, right? Because we got to subtract the 9. So we have 4x is equal to negative 9. Divide by 4, so x is equal to negative 9 over 4. Okay, just make sure when we're solving for our variable that we're always using the opposite sign. So if this is plus 9, then we use minus 9. And since this was 4 being multiplied by x, that's why we divided both sides by 4. Okay. And so that's the first part. And so ultimately what we're finding and what we'll point out in the next note is that you are finding the roots or the solutions to quadratic equations, okay? We don't do too much graphing of the quadratic equations in this course. That would be more college algebra. But when you get to college algebra, once you get these steps, you could plot these points that we found for the x values on the coordinate plane. It would help you draw your parabola, whether that's the U shape or the upside down U shape. So just extension for the next course. Okay. So the next concept is solving equations by factoring. So now they're going to give us an entire equation. We're going to have to use what we learned in the previous notes to factor. And once we have those factors, we're going to set each of them equal to 0, just like we were doing in the first part. Okay. So the most important part here is to make sure that this is in standard form. And recall standard form is ax squared plus bx plus c equals 0. Okay, very important that our quadratic is always equal to 0. So looking at this example, is this in standard form? No, what would we have to do in order for it to be in standard form? Good, I would have to move this 5 over. So I have 2x squared minus 9x minus 5 equals 0. So now I have a, which is 2, b, which is negative 9, and c, which is negative 5. I have my a, b, and c value. Okay, so from here, I'm going to take a times c, and what do I get when I do that? A times c. Negative 10, and then I'm finding two numbers that multiply to negative 10 but add to what number? B, which is negative 9. Good. Okay. Good, negative 10 and 1. So remember, we could list out all the factors if you're not sure, okay? Or if we're able to think of it right away, we can write that down. So our factors would be negative 10 times 1. That would give us negative 10. And then negative 10 plus 1 gives us negative 9. So you know negative 10 and 1 are good factors to use. So I'm going to expand my b value. So that's 2x squared minus 10x plus x minus 5 equals 0. So again, I use these two values and I put them here. So now that I expanded my b value and I have 4 terms, I'm going to do factor by grouping. So I'm going to do the first 2 and then the second 2, and then I'm going to take out what from each parentheses? A GCF. So what can I take out of the first one? 2x. So if I take out a 2x, what am I left with? X. What else? Minus 5. Okay, because the 2 and the 2 cancel. I have 2 x's here. If I take out 1, then I have 1 left. And then I do negative 10 divided by 2, which is negative 5, and then the x's would cancel. Okay? Not quite, because we still got to take a GCF out of here. But since these match, what am I technically taking out so it doesn't change? A 1. So I'm going to do plus 1, which means I still have x minus 5 equals 0. Okay? Which means my two factors are going to be x minus 5 and 2x plus 1 equals 0. Okay, so on the previous notes, we stopped there. We did not continue and solve, but here we're going to solve because we have that equal to 0. So that means I'm going to take, I'm going to carry on over here. X minus 5 equals 0, so I'm going to do that one first. So that means what am I going to do with that minus 5? Good, add it over, so x is equal to 5. That's my first answer. And then I have 2x plus 1 equals 0. And so in order to get x by itself, what am I going to do first? Subtract the 1, so I have 2x is equal to negative 1. And then divide by 2. And I have x is equal to negative 1/2 because I'm going to leave everything as a fraction. Which means my answers or my solution to this quadratic equation is 5 and negative 1/2. Okay, so we're now we have combined the past couple notes into this one. And this was the end goal for this topic was, okay, can we take an equation, factor it, set it equal to 0, and solve? Okay. So let's look at the next one. Okay. Our first step is to make sure that it is what?
In the quadratic expression.
Good, in standard form, in the quadratic equation. So does this look like it's in standard form?
No.
No, what do we have to do? Good, add the 24 over because our equation should always be equal to what? 0. Okay, so now that I have it in standard form, I'm going to label my A, B, and C. What is A?
2.
Okay, B? Good, and C? Perfect. So then when I factor this, I'm going to do A times C, which is 48, and then bring over my B value. So I need two numbers that multiply to 48 but add to 19. 3 and 16? Yep, 3 and 16 works. So 3 times 16 gives us 48, and 3 plus 16 gives us 19. So that's how we know we're using those two factors. However, remember, if you can't think of them, you would go through and you would list all the factors. You would start with 1 and 48, 2 and 24, 3 and 16, so on and so forth. And hopefully when you saw 3 and 16, you noticed, okay, hey, I got to stop here and see if those would add up to 19, which it does. Okay, so then I write that. So 2y squared plus 16y plus 3y plus 24 equals 0. Okay, so I took 3 and 16 and put them here. And I decided to flip them so the 2 would go with the 16 and the 3 would go with the 24. Do I have to do that? No, you're going to get the same answer either way, but this just makes it easier for me to take out a GCF. Okay, so now when I group them, what would be the GCF of the first one? Good, 2y, which means I'm left with... Oh, you were going completely? That's okay. Y plus 8, good. And then if we want y plus 8 in the next parenthesis, what GCF are we taking out? A 3, good. So we're left with y plus 8. And then don't forget to bring down that equals 0. That's the only thing different than what we were doing the past couple days. Yes. Yes.
The size of the box is small.
Yes.
Is it okay if you can use like notebook on test? Just like to have our answers, or just like rip the page off.
Rip the page off and stick it in. Sure.
Okay.
Yes. Or just write very, very small, right?
I can't write that small.
Right into the margins off to the side. Draw an arrow to the top, like this. Draw an arrow up here and continue up here.
The luck of using an iPad.
Yes, I know. Yes, I know. Because I can zoom in as much as I want. Okay, so from here, what would be my next step? Y plus 8 and 2y plus 3 equals 0. Okay, so then I have to set them each separately equal to 0. So I have y plus 8 equals 0, and then 2y plus 3 equals 0, and I have to solve for each of them. So in the first one, what am I doing? Minus 8. So I have y is equal to negative 8. Okay, and then the next one? Minus 3. So I have 2y is equal to negative 3. Divide by 2. And I have y is equal to negative 3 halves. And I always just leave it as a fraction. Okay, so if it asks you to take this equation and find the solutions, that's what we're doing in this process. We're factoring, setting the factors equal to 0, and we found two solutions, negative 8 and negative 3 halves. Okay, so then we get down to something that looks a little different. Okay. And now if we look at this, does it look like the standard form?
No, it's only 2.
It's only 2, which means it's missing what value? C. Okay. If it's missing the C value, then the first thing you should do is always factor out a GCF. Okay, these are actually easier because we don't have to do the whole factoring part. We're just taking out a GCF. So what would be the GCF here? 4x, which means I'm left with plus 6. Good. Equals 0. Okay, so just like on the beginning part of the notes, I'm going to take each of these. I'm going to pretend this is in parentheses. And I'm going to set each of those parentheses equal to 0. So I have 4x equals 0 and x plus 6 equals 0. Okay, so how would I solve the first one? Divide by 4. And what's 0 divided by 4? 0. So x is equal to 0. There's my first answer. And then what about the next one? Good, I subtract 6. X is equal to negative 6. That is my second answer. So yes, these ones are easier because we don't have the C value. And so we just go straight to taking out a GCF. Okay. Any questions so far? Sorry? Like when it's like this, we take it out, always the first parenthesis equal to 0, always this next parenthesis equal to 0, whatever is in those parentheses. Yeah, they always should equal 0. I guess I'm confused on the question. So you'll see later, you'll see, okay, we have something that looks like this that maybe has a number on the other side. And we know that we can't continue unless it's equal to 0, which means looking at this example, what would we have to do first? Before GCF.
Move the 45, right?
Move the 45 because we have to make it look as close to standard form, that quadratic form, as much as possible. So we have 5x squared minus 45 equals 0, which means now we're missing what value? Good, the B value, the center value, okay? So we're still going to look at this and take out a GCF. So what GCF can we take out? 5. So if I take out a 5, I'm left with x squared minus 9 equals 0. And then you should look at this and say, hey, we did that yesterday. Which means how would we simplify this factor? The square root, okay? So where we did yesterday, where we said a squared is equal to x squared, which means a is equal to x, and then b squared is equal to 9, which means b is equal to 3. We take the square root of each, and within the parentheses, we're going to have one positive and one negative. So I bring down the 5, and I have x minus 3, x plus 3 equals 0. Okay, so again, this is bringing in the notes also from yesterday with those special cases. Okay, we're still setting everything equal to 0, including that 5. Okay, because I want you to get in the habit of setting everything equal to 0. However, if I do 5 equals 0, does that make sense? No, this is a false statement, which means I just skip it. Okay, it doesn't make any sense, I skip it. Okay, and this is again to get you in the habit of setting everything equal to 0. So now I do x minus 3 equals 0 and x plus 3 equals 0. Which means on the first one, I get x is equal to 3. And on the second one, I get x is equal negative 3. So how many answers do I have for this equation? 2, right? I have positive 3 and negative 3. And this doesn't count because that gave me a false statement. 5 cannot equal 0. That doesn't make sense, so I skip it.
Is that the 5 that we're supposed to read out?
Yes, and we brought it down. That was our GCF, and we brought it down here. Once we bring it down, since everything's equal to 0, we have to set every single part equal to 0. Okay. Okay, and then we get something a little bit more complicated, right? Now it doesn't look anything like our standard form. Okay, which means we need to try to simplify it as much as possible in order to make it look like that standard quadratic equation. So looking at this, what do you think our first step would be?
Carry the 10x to the 5x?
Not quite.
5x times 5x.
The parentheses, right. Do you guys recall PEMDAS?
Yes.
Okay, PEMDAS stands for parentheses.
Exponent.
Exponents. Exponents, good. So, sorry. Thank you. So exponents, so think like x squared, right? Exponents. What's m? Multiply. D? Divide. A? Add. S? Subtract. So when you think of PEMDAS, these can be interchangeable. It doesn't mean you do multiply then divide, whatever comes first. And same with addition and subtraction, whatever comes first. But since the beginning of PEMDAS is parentheses, that's how I know that I'm first going to distribute the 5x in to get rid of the parentheses. And so 5x times 5x, 25x squared, and then 5x times 2, 10x, and then I bring everything else down, so equals 10x plus 9. Now that I have the parentheses gone, my goal is to have this equation equal what? 0. So what am I moving over? Good, I'm moving over this 10x, so subtract 10x, and I'm also going to move over the 9. Okay, which means I have 25x squared. What happens to those 10x's? Cancel, because one's positive and one's negative, which means I'm left with just that minus 9 equals 0. Okay, so I have an a value and I have a c value. So what method am I going to use to factor this? Not GCF. I can't take out a GCF.
9. Square roots?
Square root, perfect squares, right? The ones we did yesterday. I know that because if I look at this first term, can I take the square root?
Yes.
And if I look at the second term, can I take the square root? Yes, so that's how I know I'm doing perfect squares. That's where I say a squared is equal to 25x squared, which means a is equal 5x. And then I say b squared is equal to 9, which means b is equal to 3, right? I take the square root of 9. So that means I have what two parentheses?
5x plus 3, 5x minus.
Good, 5x plus 3 and 5x minus 3. So remember, with these perfect squares, one parenthesis is positive, one is negative. And it doesn't matter which one, okay? The order doesn't matter here because we're multiplying, as long as one has a positive and one has a negative. But I'm solving here, so what's my next step? Set them equal to 0. See, I ran out of space. It's okay. So 5x plus 3 equals 0 and 5x minus 3 equals 0. Okay, so if I was solving the first one, what would I have to do? Subtract the 3 and then divide by 5. So this is x is equal to negative 3/5. Right, I subtract the 3, which gives me negative 3, and divide by 5. And then I leave it as a fraction. Okay, so knowing that, what would be the answer to the next one? A positive 3/5. So this is x is equal to positive 3/5 because we would add the 3 over, then divide by 5. Which means this has how many solutions? 2. 2 solutions. Okay. Okay, go ahead and take a minute and try this one and then compare with a neighbor. Same steps as the one we just did. Bless you. And then as soon as you're done, go ahead and compare with the neighbor. We will find out. I don't have the key in front of me. Okay. So the first steps, if you're still working, of course, still try to get through the whole problem, but I'm going to start going through the steps. So the first step was to distribute the 4z. So we have 4z squared, because 4z times z, plus, what's 4z times 3? 12z. And then bring everything else down. Okay. And then our goal is to get this equal to what? 0. So what are we moving over? 4z and the 5. We're bringing all of that over. Which means we have 4z squared plus 12z minus 4z minus 5 equals 0. Can we combine any terms?
12z, 4z.
Good. 12z minus 4z gives us 8z. Okay, so now we have it in standard form, that standard quadratic form. So now we're going to factor. So in order to factor, we're going to do a times c, which would give us negative 20. Okay, so negative 20. And then we're trying to add to what b value? 8. Okay, anyone think of those numbers? 2 and 10, which one's negative? 2. Okay, so negative 2 times 10 gives us negative 20. And negative 2 plus 10 gives us positive 8. So that's why we're using negative 2 and positive 10. So then we have 4z, oh, I forgot the squared. Minus 2z plus 10z minus 5 equals 0. Okay. And then from here, what's my next step? Factor by grouping, and then I'm going to take out a GCF. So what's the GCF from the first one? 2z, and I'd be left with 2z, right? Because 4 divided by 2, we still have 2. So 2z minus 1.
No, we wouldn't. Oh, yeah, we would put the square. Okay.
And then what am I taking out of the next one?
2z plus 5. Oh, it would be
5, right? Because I want it to match. I want the 2z minus 1 to match with the other parentheses. So if I take out not a negative 5, just a positive 5, then I have 2z minus 1. Okay, because 10 divided by 5 is 2, negative 5 divided by 5 is negative 1. And then this whole thing is equal to 0. Okay. Then from here, I know my two parentheses are going to be, and 2z plus 5 equals 0. And then my last couple steps is I'm doing what with each of the parentheses? Setting them to 0. So 2z minus 1 equals 0. 2z plus 5 equals 0. So on the first one, the first thing I have to do, add 1. So I have 2z equals 1, which means z is equal to 1/2 when I divide out that 2. Okay, and then on the next one, my first step would be, subtract the 5, and I have 2z is equal to negative 5, which means z is equal negative 5 over 2, because I have to divide both sides by 2. Which means this quadratic equation has how many solutions? 2. 2 solutions. 1/2 and negative 5/2.
Is it ever going to be more than 2 solutions?
Eventually. Eventually. I'm trying to remember if you see it in this course. Well, yeah, actually, in the next problem, we'll have more than 2. Yes. So we see it a little bit in this course. You'll see it more in college algebra. I know I keep saying that, but this is more of like, surprise, here's what everything looks like, and then you go into depth in college algebra. Okay. So yes, you will have more than 2. And so you see that in this example here. And what do you notice about this example that's different than the rest? There's 3 parentheses, and that means there's how many total y values? 3. That's how I know there's going to be 3 solutions. Okay, there's 3 y values. There's 3 parentheses. And also, do we have to factor anything? No, they already did this for us. So what do you think we're going to do with each parentheses? Set it equal to 0, okay? Including that very first number, that negative 6, because we want to get in that habit of setting every single part equal to 0. However, when I do negative 6 equals 0, does that make sense? No, so what am I going to do? Skip it, right? I'm going to say this is false and skip it. Then I'm going to do y plus 3 equals 0, which means y is equal negative 3. That's my first solution. Then I have y minus 5 equals 0, which means y equals 5, because I add the 5 over. That's my next one. Then I have 2y plus 7 equals 0, and what would be my first step to solve that? Minus 7. And so I get 2y equals negative 7. Divide by 2, so y is equal negative 7 over 2. We leave it as a fraction, which means this equation has how many solutions? 3 solutions. Okay. And really, this is no longer a quadratic equation, because if we do y, nice here, if we do y times y times y, that's going to be y to what power? 3. So what is something to the 3rd power? Cubic function. Yep, to the 3rd power is a cubic function. So from here, we no longer have that quadratic. We're just using the 0 product rule to solve a polynomial. Okay, polynomial means anything with a certain degree, x squared, x cubed, x to the 4th, so on and so forth. Okay. Okay, so go ahead and try this one. Okay, give you guys a minute. Remember, we're setting everything equal to 0. So just by looking at this, how many solutions are we going to have? 3. 3 solutions. And then as soon as you find those solutions, go ahead and compare with your neighbor.
We never put these in decimal, right? Decimal form?
So if you put it in decimal form, I'm not going to mark it wrong. But in college algebra, they want everything as fractions. So you should get in the habit of doing fractions. Yes. Okay, so when we solve this one, we set every single part equal to 0. So what does it mean if 5 equals 0? That is false. So what do we do with it? Skip it. Then we do p minus 4 equals 0, which means p equals 4. That's our first solution. Then we have p plus 7 equals 0, which means p equals negative 7. Okay, then we have 2p minus 9 equals 0, which means p equals 9 over 2, because we add the 9 over and divide by 2. So 9 over 2, which means we have how many solutions? 3. 3 solutions. Okay. Okay, now we have the last couple. So another one that looks different because instead of 3 terms, we have how many terms? 4. And anytime you have 4 terms, you should always do what? Factor by grouping, always. I'll make that note again on the notes. 4 terms equals factor by grouping every single time if you have 4 terms. Okay, so we do factor by grouping, which means we're taking out what from each one? A GCF. And what GCF can we take out of the first one? W squared. Why can't we take out a number? Good, there's no number that goes into 1, which is in front of W cubed, and 5. Okay, so if we take out W squared, what are we left with? W plus 5. And then if we want W plus 5 again, what should we take out of the second parenthesis? A 9 or a negative 9? Negative 9, because we want a positive W when we take it out. So this is W plus 5, because negative 45 divided by negative 9 gives us a positive 5. Okay, equals 0. Which means we have what 2 parentheses? Good, so W plus 5 and W squared minus 9. So before we continue, we have to make sure it's all simplified. Is this one simplified? Yes, what about this next one? No, and what factoring method are we using? Perfect squares, right? We're taking the square root. That method is called perfect squares. So that means we have a squared is equal to w squared, which means a equals w, and b squared is equal to 9, so b is equal to 3. Remember, as we keep doing this, you don't have to write this out. So like on the test, let's say you're able to do it in your head, you will not have to write this step if you don't want to. Of course, if it helps, write all the steps. Okay, which means I'm going to bring down my w plus 5, and then what is my other 2 parentheses going to look like? Good, w plus 3, w minus 3. So if I look at all these w's in my parentheses, this tells me I'm going to have how many solutions? 3. 3. And what do I have to do with each of the parentheses?
To 0.
Set it equal to 0. So W plus 5 equals 0 means W equals -5. W plus 3 equals 0 means W equals -3. And W minus 3 equals 0 means W equals 3, positive 3. So I have these 3 answers. Okay, and go ahead and take a moment to try the last question. Okay, so we have 4 terms here. So that tells us we're doing what method? Factor by grouping. Okay. So factor by grouping, what GCF can we take out of the first one? X squared, and we're left with x plus 3. And what can we take out of the next one? So we're left with x plus 3. -4, x plus 3. Which means we have what parentheses?
X plus 3 and x squared minus 4.
Good, x plus 3 and x squared minus 4 equals 0.
And then use the perfect square for the x squared minus 4.
Good, and then we have to simplify further using the perfect squares of x squared minus 4. So that tells us we're taking the square root of each. So let's see if we could do this one in our head. We bring down the x plus 3. What would be the next parenthesis? X plus 2 and x minus 2. Okay. Again, we know that x squared minus 4 is the same as saying a squared equals x squared. So that means a equals x, right? And that's where we got these x's. Okay, and then b squared equals 4, which means b equals 2, and that's where we got the 2's. Okay. So then from here, are we done? Is this our answer? No, not our answer. What do we have to do next?
X plus 3 equals 0, x plus 2 equals 0, x minus 2 equals 0.
Good, set them all equal to 0. And then solve. So x plus 3 equals 0 means x equals -3. X plus 2 equals 0 means x equals -2. And x minus 2 equals 0 means x equals 2. So how many solutions did we have? 3 solutions. Okay, and I knew that from here because I had 3 parentheses with 3 x's in them. And I could also see here because this 3 in the exponents was the highest degree for all of my terms because I had 3 and then 2. So this was the highest. So this tells me I have 3 possible solutions.